Here is the next example. Here he's asking us to find Ix. Okay, so since we have three sources, it is impossible to solve this by using series parallel combination method and star delta method. Okay, we have to use KVL, KCL, or both. Okay, if I apply KCL, for sure it's going to be a lot easier. That's called by using nodal analysis. At the end I might show you how to do that, but here a simple way, it may I mean looks like it's a simple, but lots of equations. I'm assuming this source is supplying I1 current, this source is supplying I2 current, this source is supplying I3 current. Okay, so finding Ix, basically Ix is nothing but negative I3. As long as I find that I3, I can find Ix, because Ix and I3, they're flowing in the same branch in opposite direction. So it's up to you, how do you want to choose? Instead of I3, we can go with Ix. So for time being, let me go with Ix. So one less step. So I'm assuming Ix current is going in that direction. So step 1, I can clearly see I1 plus I2. So these two currents are coming in. If I apply KCL at that node, I1 plus I2 equal to Ix. Okay, so I'm going to say node A. At node A, apply KCL. That's what I did. Now, according to my I1 direction, I'm going to assign the positive and negative sign across each resistor. So this is positive, negative. So current passing through this is I1, so plus and minus. I2, that's plus and minus. Ix, that's plus and minus. That's plus and minus. Okay, so here is first equation. Now it's up to you. As I mentioned, you can apply KVL or KCL. So here I'm going to, how many unknowns I have? I have three unknowns. One is I1, I2, and Ix. So I have that first equation. Now my second equation, I'm going to apply KVL around this loop, this outer loop. Okay, now apply KVL across the outer loop. Okay, so if I follow the outer loop, is this a voltage drop or gain? That's a voltage drop, which is 10 times, because I'm entering the positive terminal. So 10 times Ix. Is this a voltage drop or gain? That's a voltage drop, because this long one is always positive. So plus 25 plus 10, what is this? This is plus 10 Ix. Okay, and plus 10 I1. Now here I'm entering the negative terminal, isn't it? Because this small one is always negative. So minus 75 plus 10 I1 equal to 0. So I end up with 20 I1 plus 20 Ix equal to plus 25 minus 75 minus 50. If I bring it to the other side, that's positive 50. That's my second equation. Okay, now all I need one more equation. It's up to you. You can choose this loop. Okay, so what I meant to say, I'm going to start walking inside this loop. Okay, so if I start walking inside this loop, loop 1, apply KVL. Okay, so if I apply KVL in loop 1, so start walking. So here I'm entering negative terminal, so that's voltage gain. So 10 I2. So here I'm writing the gain, here I'm drop. Okay, in this case I'm on this side, drop equal to gain. So 10 I2 is gain, 45 is a drop, and plus 10 I1 is a drop, minus 75. I mean, that's a gain, so I can write it down on the other side. Okay, and that's a drop plus 10I1. Okay, this is the equation. What I did in the previous case, I always practice this. So what I did, if you are entering the positive terminal, take that as a positive, entering that as a negative terminal, take that as a negative, and make it equal to 0. So all I did, even the gain part, I write it down on this side. I should have write it down the 75 on the other side, make it as a gain. But this equation is also right, okay, the way I wrote. So this is also right. So I have 20I1 minus 10I2 equal to 75 minus 45, which equal to 30. This is my third equation. So I have three equations, three unknown. My goal is finding Ix. Let me solve this. So equation 1 multiply equation 1 with 10. So I will end up having 10I1 plus 10I2 equal to 10Ix. Now equation 3, I have 20I1 minus 10I2 equal to 30. So when I add them, these two get cancelled out. So 30I1 equal to 30 plus 10Ix. Okay, so I can write it down as 30I1 minus 10Ix equal to 30. This is my fourth equation. Now if you look at the second equation, I have 20I1 plus 20Ix equal to 50. So if I simplify this, can I write this as 10I1 plus 10Ix equal to 25? I just multiplied with 0.5. So this is my equation 2. So what I'm going to do, I'm going to write down equation 2 here. 10I1 plus 10Ix equal to 25. This is my equation 2. Now I'm adding these two together. So Ix get cancelled out. 40I1 equal to 30 plus 25, which is 55. What is I1? I1 equal to 1.375 amperes. But our goal is finding Ix. So 10, I'm going to substitute I1 value in this equation, equation 2. Okay. So 10 times 1.375 plus 10 times Ix, which we don't know, equal to 25. So 10 Ix equal to 25 minus 13.75.